assume, but just represent that each of the IDs, these are all primary keys. So we're just gonna paste this just to save some time. Whoops. I don't know what happened here. There, okay. Paste. Okay, so now we have our tables together, and anywhere you see a primary key in another table, that's what's known as a foreign key. That's how the tables will interrelate with one another. So we'll describe them as such. This table will have quite a few. So almost the whole table is made up of foreign keys. Foreign key here, foreign key here. This one doesn't have a foreign key. That's perfectly okay. And what we want to do is kind of match the colors. Match the colors. And this is that color. This is blue. Probably this blue, right? No. Pretty sure it's the blue. It looks different, but it's okay. Lime green, and then light green. And so anywhere there's a foreign key now, we want to color code that too, just so we understand, we can represent what's going on. So for address, that's green. For product, that's blue. For payment, it's light green. For ship ID, it's like an orange or pink. In product, we have category ID, so we're gonna put light yellow. And then those are we were missing one. So there's a foreign key in customer ID. So we'll make this gray, like a grayish color. Oh, here it's like a blue. And so this doesn't really do anything in terms of the actual database. It's just a way to conceptually understand what's happening. So, for example, address has no foreign keys. Address goes into customer goes into shipping, and then shipping goes into order. For payments goes directly into order. For categories goes into product, and then product goes into order. I believe that's all of them. But the main point is that nothing is relating with itself. Address goes into customers. For every customer, there's one address, so one to many. And then going into shipping, for every shipping address, there should be one customer. And then that'll go into orders. So shipping will go into orders. So for every shipping address, there should be one order. And then for every payment, for every method of payment, I should say, that goes with one particular order. Remember, there can be a whole bunch of orders, but one order is not going to have multiple customers at the same time. One order goes with one customer. So that's what I'm trying to explain here. Same thing with product. You're ordering a product. I guess you could be ordering multiple products. So that might not work in this instance, but just for the sake of getting to the point where we have a fake database, we'll leave that to an actual database administrator to critique the video in this part. But again, we're just trying to get something up and running. We can sort of understand there's one-to-many relationships. We don't want any recursive relationships. That's the main takeaway point. No recursive relationships. So we've designed the database. We have an idea of how to connect everything. Now let's actually generate fake data. So what I found to generate fake data is this website called Mockaroo. And the thing I like about this data generator, I guess you could say, is you can pick any type of data type. I mean, it's limited in some capacity, but as a whole bunch of data, I'm not sure where they generate this data from, but real life-ish data that you can use and to create fake data. Again, you can just go on Kaggle or go on data.org or some type of database, I guess, search engine, and find a topic that you're interested in. I just couldn't find anything that I would be necessarily interested in. So I thought it would be way more interesting to generate fake information. So with that, we can now, I'm putting a split screen here. We can design, for example, the customer table. So let's do, customer ID, right? Now, what I've found is for the ID, and also it already has this here, so I'm assuming that that's what you should be doing anyway. For customer ID, row number would be what you put. You can make however many rows you want and whatever format you want. We're just going to do 1,000. Because you can even just do less, 100. All you need is like a couple of rows so that you can join them and you can say, hey, I've made a join. So we'll start with customer ID. We already have first name here, but let's just follow the pattern. We got email. And now I'm realizing it. I did miss you're supposed to put the data type here. For all primary keys, when you use actual database definition a notation, or when you create table and auto increment and all that stuff, you want to have this noted so that way you make sure that you create the code correctly. So we want the primary keys to auto increment, because if it's a natural setting, as each data is inputted, it would go on to the next primary key number. For our foreign keys, we just want to make sure that they're not null and that they're integers. So let me just fix that up right here. And for any type of text, remember, we're going to be changing this anyway. Or not so much that we're going to be changing it, but we're going to have to input the data in as all characters anyway, because that's what I found is best to put in the data. So we'll just continue this process. For email, phone number, first name, last name, they're going to be characters. For tracking number, you want that to be digits. Doesn't necessarily have to be 12 digits. Shipping date, you want that to be date and time. Shipping company, those are just characters. For category, you kind of want to avoid the habit of just putting varchar for all of them, but just for the sake of finishing this up. Payment type, whether it's credit or debit or Master or Visa card, you can put the set notation for that. Payment number, again, this is just to show you when you're designing a database, you're taking into account all of the information, so when you go to write your creation of the database, everything's there for you to create from. Fulfillment status, unfulfilled, filled. Remember, these are now foreign keys, so you just want to make sure it's not null and that it's an integer. Product name, varchar, price, make sure that's an integer too. In fact, it should probably be a float, but again, we'll change that as we go. And then finally, address, abbreviation for state, integer not null. Now we've completed it. We can just straighten this out. Okay, that looks a little bit better. So now we have something to go by when we're creating our mock data set. Just going back to this one, customer ID, we'll go with email. In fact, let's just exit out of all of these, add another field, email. You can even search the data type. So if you want an email address, you can have a fake email address. Next one will be phone number. So this is not necessarily SQL, but I think it's interesting how you can get the data as accurate as possible. You can even mess with the format of the numbers. That looks good to me. Oh, also another thing, when you have real life data, there can be some nulls in it. So we'll put a certain percentage of nulls that are blank. I'll say like 1% for everything. So we'll do first name, and this even has a thing for first name. That's why I like it so much, because you can make realistic-ish data. Last name, and then address ID. We're going to make it the same data type for this mock data set. So row number, because when we export the CSV sheets and we put them into the database, the way they're going to connect is that they're going to have the same, it's going to be row number, but I'm using that as the primary key. In real life, they would not be sequential and they would not be in order. They would be, there would be rows that have been deleted, rows that have been created. So it's not going to be perfectly set up that way. So we have this table, we have the customer table done. And so what I like